Hello, this is video 68. This is the first video on the topic of fluids. So before we can talk about fluids, which are liquids and gases, we have to define what is density, because we'll be talking about density a lot in this unit. So density is the mass per unit volume of a substance. So we use the letter rho for density equals mass per volume. And you can see this picture of the strongman here. He's squishing the bread. So what do you think is happening to the density when he's squishing the bread? Well, the mass doesn't change when he squishes it, but the volume gets smaller. So when you make the volume smaller, since it's in the denominator, then the density is going to get bigger. And you know that from experience that the bread gets a lot more condensed when you squish it. The units for density are the kilogram per meter cubed. That comes from mass is kilograms and volumes is meters cubed. This is a scalar, it does not have a direction. And then in this slide I put two common densities that we're going to use, especially the density of water. You're probably going to have it memorized very soon. That is 1,000 kilogram per meter cubed. But it is on the equation sheet, so you don't have to memorize it. And then I also gave you the density of seawater, which is 1,025, so it's just slightly more dense than fresh water because there's salt in it. So if a problem does not give you the density of the seawater, but you know that you have seawater, then just use 1,025. But some problems will give you 1,030, so just use whatever is given. So I have a your turn conversion here, and you've seen this before in one of my first videos. This is just a refresher because you're going to be given the density in different units, such as grams per centimeters cubed. If you have taken chemistry, it's often written in grams per centimeters cubed, but we're going to want it in kilograms per meter cubed. So just a refresher on how we convert these units. So we write down what we are starting with, 1 gram per centimeter cubed, and then we have to come up with two different conversion factors to cancel out the grams and the centimeters cubed. I'll cancel out the grams first. We have 1,000 grams in 1 kilogram. So I'll write the grams on the bottom so that they cancel out. And then we need to cancel out the centimeters cubed, so we'll put those on top. Put the meters cubed on the bottom that we want. We know that we have 100 centimeters in 1 meter, but since the unit is cubed, we have to cube the prefix as well. To convert 1 gram per centimeter cubed into kilograms per meters cubed, we end up dividing 1 by 1,000 and then multiplying the whole thing by 100 cubed. You can see that the centimeter cubed cancel out, and we're left with kilograms per meters cubed for our units. And if you do 100 cubed divided by 1,000 times 1, you will get 1,000. Another reason that I have this your turn, besides just practicing converting units, is because this is the density of water that we just saw in the previous slide. And it is possible that sometimes you are given that density of water in grams per centimeters cubed. So if you realize that the density of water can be written as 1,000 kilograms per meters cubed or 1 gram per centimeter cubed, then you don't have to do this conversion every time. You can kind of remember that. But you don't have to remember it. You can always derive it. I have one more example for this video. So this one is to calculate the mass of air in a living room with dimensions 5 meters times 6 meters times 3 meters. We are given the density of air. You notice it's 1.2 kilograms per meter cubed compared to 1,000 for water, so it's way less dense than water. This is just a problem to practice the definition that we just learned, that density equals mass per volume. We're looking for mass, so we multiply both sides by V, and we get mass equals density times volume. We need to find the volume. The volume, we're going to assume that it's a rectangular room with those dimensions. So the volume of a rectangle is length times width times height. So we're just going to multiply the 5 meters times the 6 meters times the 3 meters. We'll get 90, and there was a meter in every term here, so meters cubed. So that's the correct unit for volume. And then we plug in here for mass density of 1.2 kilograms per meter cubed multiplied by 90 meters cubed. You can see that the meters cubed cross out, and we're left with 90 times 1.2, which is equal to 108, and we're left with kilograms here. So another reason for this example, besides finding the mass of the air in an average size room, is to start the idea here that air does have mass, so air does have weight that we feel on our bodies all the time. This is going to be related to the pressure due to the atmosphere that will come up in a video very soon. And then the other reason for this example is this expression right here. In this chapter of fluids, we're often going to replace the mass of something by its density multiplied by its volume. Especially when we're talking about liquids, which we are in this chapter, we often have the density of the liquid. So just get used to seeing density times volume and just think to yourself, okay, that's just a mass. Just a different way to think of it. So that's all for this video. The only thing that we really talked about in this video is a definition of density equals mass per volume.